Started. Uh, Hi, good evening, everyone, and welcome to the second day of the workshop on data visualization using Matplotlib and Seaborn. So yesterday we saw the basics of Matplotlib, where we understood the concepts of figure, axis, how to build them, how to give the title to the figure, how to give the title to your axis, and how to give the titles to your x-axis and y-axis. We also understood how to make various axes and plots, various kind of plots. During that, we saw the markers also. We saw the line spaces also, and we understood the various intricacies. So taking from that, I will just share my screen and let's start. Please give me a just hands up, someone, once my screen is visible to all of you. Thank you. Thank you so much. Okay. Okay, let's start from our yesterday's session. So yesterday we had understood various types of charts also. So there are basically 12 types of charts, and out of that, most frequently 5 or 6 charts are used. Now for today, before we commence, we will try to find the answers for some questions which were raised, and I will also give you some additional resource for building, animated dashboards. I will not be utilizing much of time on explaining that. It is a resource for you to utilize. I'll be sharing the collab. Yesterday, recording and the collab file was shared with all of you. So I hope all of you have assimilated that. So the first question somebody had asked me that can you, have the different types of axes. For example, when we built those 4 axes in 2 rows and 2 columns, all the axes they had the similar size. So first question is basically how to change the size of one axis, not the whole figure. So for that, Matplotlib has got something called grid spec, and you have to import that from matplotlib.gridspec, and you can import it as a grid spec. So what do? We build the data. For example, here by using numpy linspace, I'm creating data from 0 to 10, and then I'm making a figure. So earlier we had seen that we were making plt.subplot, and default it was giving us fig and x. These are the names. However, if you want to make only one figure, then you can make it using plot.figure, and in argument you can give the fig size, which is in inches, which is in width and height. So this command is basically to make the figure. And now in this figure, using the grid spec, we can make different axes with different sizes. So the command is grid spec 2 2. This 2 is number of rows, 2 is number of columns. We are giving argument figure is equal to fig, which we have already just now we defined. Now here, these are the 2 arguments which are used to change the sizes. So width ratio is 2 and 1. It means the first column width will be double of the second column. And similarly, height ratio 1 is 1 and 2. It means the second row height will be double of the first row. So by using this command and using the grid spec, you can change the sizes of your axes. And now we define our x1. So in this figure, we add subplot. The GS is the grid spec. So GS00 is the first row, first column, that is x1, then x2, x3, x4. And like we learned yesterday, we give that plot, for example, in x1, we will plot x and sine of x. we are giving the title. In the second plot, we are plotting cosine. In third, a random. And in fourth, we are on random on X, and we are plotting a histogram with bins is equal to 30. So let's see how does it span out. Okay, so you can go through the concept. We are using grid spec, having the data, then defining a figure with a figure size, and using the grid spec, I'm making an object GS where I'm giving figure is equal to fig and defining the width ratio and the height ratio. And then X1, X2, X3, and X4, I'm adding to my figure by adding subplot. And on that X1, X2, X3, and X4, I'm plotting. So see, it has come. So what we had defined that the first column width will be double of the second column. So you can see here it has, we can see the first column is twice wide than the second column. And similarly for height, we had defined the second row will be having height double than the first row. So I hope with this I have been able to answer that question which was asked yesterday. Any query?
Yes, sir. Yes, sir.
That's, the second question was that when we are defining this axis and I want to say that I don't want to see the X4. So how to do that? So there are two options for you. Either you can just turn it off by command that you give the name of the axis.
So your screen isn't visible.
Okay, I will share again. Is it visible now?
Yes, sir.
Okay. So the second question was that how we display or hide one axis. So for that we can have two approaches. One, either we just turn it off by using this command, which is giving the axis name dot axis off string. So by that you can just turn it off, or you can also remove it by using the delete command. So in first, for example, I'm making fig and axis standard command 2 fig size is 64. I'm plotting on axis 0 0 0 1 and 1 0, and 1 1 dot axis I'm switching it off. I'm turning it off. Tight layout, and by that now you can see that 1 1 will not be visible. So this is the command for not displaying. The similarly you can do by deleting it. So for that the command is you have to give it a figure, your name of the figure fig dot del axis and the name of the axis. So by that you are deleting and you receive the same effect. Okay. So having covered these two concepts, so first concept was to have different sizes of the axis. For that we use grid spec. Second, for hiding one axis, we either switch it off by using axis off or by deleting it. So for deleting is del axis and giving the name of that. Now we come to another very important concept, which is used basically when you make dashboards. So for example, in the top row, you want to merge both axes to have a larger axis, and in below you want to have two axes. So that you can achieve by merging the axes. So key idea is basically that the GS which we had formed, so GS 0 to hash, it means all the rows in the 0th row and all the columns now will be merged in this. So in this again we make a data, we make a figure. Now using the grid spec we have made GS, and here this is the one, the fig add subplot. If I use GS 0 to hash, so in the first row everything, all the columns now they will be merged. So on the top you will have only one axis, and here in this, for example, I had defined the name of this X big. I'm plotting X and the sign of X, And then on X1, GS10, that is the second row, first column, and the second row, second column, I'm plotting cosine and I'm plotting random numbers. So let's see how this happens. Okay. So you see on the first, you have got the merged one where we have plotted the sine, and on the second, we have got cosine and we have got random noise. So like I mentioned earlier, this concept you can use when you are building dashboards. Okay, so any question, any query regarding these three concepts before we move to on the second concept? Any question, anyone? Okay. So I hope my delivery is okay. Am I too fast? Am I too slow? You want me to slow down? You can pipe up.
Sir, in the merged axis case, are there 3 subplots or 4?
So there were we built 4 subplots. See here. Okay. Just I will go command by command. So here you see GS grid spec 22. So this is grid spec 22 means number of rows is 2 and number of columns is 2.
Okay, sir, clear.
Okay. Yeah. And like I mentioned yesterday, these sessions will be interactive. Anywhere you face any doubt, you can always pipe up and we will discuss that out immediately. Okay. Now the second two concept, okay, like I mentioned, why this is powerful. So this basically when you prepare the dashboards, you want to have different things in different sizes, you can build that. Now this is the one additional resource I'm giving to you for making animated dashboards. So this is beyond the scope of the workshop, covering basically Matplotlib and Seaborn for data analysis and machine learning work. So this is for building animated dashboards where you want your dashboards to live. So what is the meaning of that? Basically, you're animating that. You're making plots move in real time. So for that, we use this %matplotlib inline, which permits us to make plots, real-time plots in Colab. For Jupyter, there is a different command for this. Now, for this very important thing which we cover for animation, from matplotlib.animation, we import func animation. This is the one. And now for displaying in Colab, I'm importing HTML also from IPython display. We make fig axis. This is the standard command. 2 rows, 2 columns, fixed size. We prepare the data. Now we give the name of the first axis 0, 0. We are plotting sine x. In the second, in 0, 1 axis, I am plotting cosine. And I'm plotting 1, 0. I'm plotting the scatter of x and random numbers. Now I'm giving the numbers here, for example, title, sine, cosine, noise, and histogram. And in 1, 1, I'm plotting this bars where I'm plotting the histogram, random numbers with bin is equal to 0. Now for having a real-time data which is dynamic in nature, I'm defining this one function which will update this. This is only for demonstration purpose. So line sin, which is my number name of my axis, I'm setting y data. So this is the command. I can use set y data, and it will change as per the np.sin x plus frame by 10. So frame is the argument which I'm giving here. I can give 100,000, whatever I want, and the data will change as per this. Similarly, for cosine, I'm changing the data. For scatter also, I'm adding a noise. So this is I'm doing. The axis 11 CLA is a command which handles the histograms. So here I'm doing that. And I'm returning all these 3 line sin, line cos, and scat, which is there. Now, by this command, any is equal to func animation. This is the func animation which I have imported from Matplotlib animation. I give figure, I give this function update, which will give me the new plots or the new data which is there. I'm giving frames is equal to 100. and I'm giving intervals, that in what intervals you have to get. And the last command basically is just to display this via HTML. Okay, now let's see how does it happen. It will take some time.
The function we have defined only for that animation.
Yes, yes.
Animation. And
Yes, yes.
we are plotting the data inside our function, update function.
Yes, yes. No, we are not plotting. We are updating our data using this function. So for example, if you are having data, for example, from stock market, which comes in every second, and you want to make a dashboard where you want to have live data display, you can use this. Now to give that kind of functionality to my data, I use this.
First, originally, go to the code. Okay, first you display that.
Yeah.
Yeah,
Okay.
please.
So here is the data. For example, here you can see, you can run it only once. So by this data, how it is changing by your update, you can see your data which is moving. Okay. So
This line, animation line came due to that update.
animation line is coming from here. Okay. First you have plotted the np.sinx. Already you have done. Or you can make a blank also. In the next example, I will demonstrate with a blank also. Okay. And here this function I'm using to make my data dynamic. And I'm demonstrating that how can you display a dynamic data in a dashboard using Matplotlib.
The data, how data is changing, because we are not changing the data. No, we have input the data, the same data. No?
So please understand this code which is there. Update frame we are giving 100.
Frame is the parameter of this update function, right?
Yes. So I will request you, please, you go through this code. I will share this collab. And like I mentioned, it is an additional resource. If you are not able to understand it, tomorrow we'll discuss. Okay?
Okay, fine. Right,
please understand this code.
Correct.
Okay. Now, for example, again, I will demonstrate. For example, we have been studying the machine learning models, and we want to plot the loss and accuracy. So we know that as the loss decreases, accuracy increases. So again, I will explain this code, and we want to see it dynamically. So like I mentioned earlier, %matplotlib inline, it tells Google Colab to render Matplotlib figure inside the notebook. If you don't use it, it will not work on Colab. I'm importing the standard libraries, and I'm using this func animation, which I'm importing from matplotlib.animation. From ipython.display, I'm importing HTML basically to display animation in a browser. Otherwise, it will not get displayed. So here it is the standard.
IPython display is coming from the Python library.
Yes.
And Matplot is coming from that. Okay.
Yeah. So fig axis, this is the standard command. We have prepared one figure, and here you see axis, number of row is 1, number of columns is 2. So 1 row, 2 columns, this is the figure size. I define the epochs. Epochs are from 100, 1 to 100. Here I am passing loss, and here I am passing initially the loss is all zeros. All 100 places loss is 0. Accuracy again, I am passing it is 0. So this is my initial data. And with this initial data, I am drawing empty lines. So I am axis 0, which is there. I am plotting epochs and loss. Similarly, for line accuracy, I am passing axis 1, epochs and accuracy. So if you plot it here, if you plot dot show, nothing will be visible. Your axis will be there. I am giving the Y limiter. So this is one thing new which you can learn. Yesterday, somebody had asked me also, I think Mr. Umapati ji, that how we can fix the x-axis and y-axis. So the command is set y-lim and set x-lim, and you can give the numbers up to which you want to see. Okay. So here for x0, I'm limiting my y-axis to from 0 to 2. For axis 1, y limit 0 to 1. I'm giving the title, giving the x level, y level for both. And now coming here, this is the function which I'm using for demonstration purpose to make the data dynamic. So here I'm giving loss I is equal to np dot exponential minus I by 20, and then I'm adding a random noise. So this is basically fake training loss and having exponential decay. It means the learning is taking place, and I have added noise to bring the realism. Similarly, for accuracy I'm improving by 1 minus loss 1 by 2. So as this I increases, as the loss drops, my accuracy will improve. So this is just artificial function just to demonstrate this animation. Now with this, the line loss which is there, I had defined my line loss name for axis 1, line accuracy for axis 1. So I'm setting y data with the loss and line accuracy with accuracy, and it is returning. So basically this function is updating my data dynamically just to see the animation. Now this animation which I'm giving the parameters figure, the function which is updating, I'm passing frames and interval. So every 100 millisecond the interval, the update call will take place and it will update the plots. And HTML NI to JS HTML, basically it converts the animation to JavaScript and then it will play inside the collab. So let's see for this also how. So this basically I wanted to just share with you, if you want to build or you are making a machine learning model and you want to visualize that, so you can use this animation also. Okay, there is some error here. My percentage matplotlib inline. Let's run again this. Okay, sometimes this does not work. So yesterday also I was working with this. Okay, it is not taking. You can use it later. If you face any problem, we'll discuss next again. Okay. Now, we have covered Matplotlib. Now I will give you certain tricks to basically to make your charts to have professional look. Okay. So first is the mastering of markers. Yesterday we had touched upon this concept markers, and we had seen that we can pass some arguments for markers. First argument is the shape. So there can be only 4 shapes for marker. First is small o, which means circle. Small s is for square. This is the upper signal for triangle, and small x for cross. So if you remember, yesterday we had tried to capital Q, which it had not worked. So these are the 4 markers which you can use. And the markers can be used in a line plot where you want to, annotate the data points, that what are the data points are there. The second argument is the marker size, which you also can pass as a MS. It gives the how big the marker is. Then the marker face color, or MFC, what is the color inside the shape, or the marker edge color, which you can pass as MEC, which is the border color of the shape. So let's see how does it work. We are making artificial data, 5 days, then passing temperature, standard way of making figure and axis. And here now I will plot a line chart, which I use dot plot. So this is X, on X-axis I will plot days, Y-axis I will give temperature, color is green, so this is the color of the line. I'm passing line style dash dash, so the line will come dash dash. Line width I can pass, so this is an argument for line width which covers the width of the line. Marker is O, marker size I can give. What is the size? I can pass marker face color, MFC yellow, marker edge color, red. I'm also passing marker edge width, which is the 2. So this adds, so if you would have plotted a simple plot without this, it would have looked a normal plot. But here with this, you can make your plot slightly better, much looking better and having a professional touch. Any query on this, anyone? Okay. Next concept we go now, writing values on the bars. So this somebody had asked yesterday. So till Matplotlib 3.3 and before that, we had to do a lot of loops and maths to find those values and then to display. But in Matplotlib 3.4, there is a magic command which is the name of your axis dot bar underscore label, and inside that also you can give the arguments how to place that bar label. So let's see how does it work. So standard, we have made the data, we have made figure X, we are passing bars. This is the bar chart where we are giving products and sales. Color we are giving sky blue, and here this is the X dot bar label. We are using this command. So we give the name of our X axis, that is X bar label. We pass where we want to use it. So we want to use it in the bars, which is the name of my plot. Padding is 3 and FMT is %.0f. It means I don't need any decimal. Padding is equal to 3 means the text 3 pixels up so that it doesn't touch the bar. Otherwise your number will touch the bar. I'm setting Y limit 0 by 250 and setting the title. Okay, so this how you can annotate your numbers on the top of your bar. Is that okay? Who had asked me, Prashant? You had asked me this question?
I asked this.
Yeah. So Neeraj, is it clear?
Yes, sir.
Okay. Now you
Sir, it
also,
will automatically show the corresponding value, right? So that we don't.
yes. So bar, basically you are plotting. When you plot a bar, it gives the numbers only. Okay. So bar, for what do you plot? You plot for a categorical data which has got numbers, the counts or the sales. Okay.
Yes, sir.
Sir, your voice was not clear.
Okay. Is it clear now?
No, sir, clear. It was clear.
Okay. Now, if I want, for example, this number to be displayed inside the bar, so for that, in here, we can pass label type is equal to center. So this is the argument. If you want inside, you can pass color, how will it look like, and it is the same, again, the same arguments which are there. So here it has come inside. The color it has taken FMT without any decimals, font weight bold. Okay. Now we come to line styles and grid lines for basically readability. So yesterday we were basically using single slash, which is for solid line, double dash, it is a dashed, dash dot basically, and we have got dotted also. Grid lines we had seen yesterday how to make that. You just pass a plt.grid brackets and it gives you grid lines. So just to display you this different lines, and just to cover a point which was raised by Mr. Umapati ji, that in the same plot, I can plot different plots also, which I will demonstrate here. So here I have made one data, which is np.linspace 0 to 10, 20 values. Here I will plot x.plot x and sine of x. I'm giving line style as dash, which is a solid line. In the same axis now I'm plotting sin x plus 0.5 and I'm giving line style is dash. Color is red, label is dashed. Now again in the same axis I will plot sin x plus 1. The line style is this hash, color is green. And I'm also giving a grid, which yesterday we had seen, and these are the arguments we can use. True, line style, that is how the grid will look like, alpha values, how thickness is this, and the color. So with this, now we see, so grid has come, your first sign is there, which is there in the solid line, then the second, this line, and the third is your dotted line. So this how we can make, we have to understand that we can plot different plots on the same axis also if you want to plot. But please check whether those plots are compatible or they will be readable, then only you decide on that. Okay. So see here, I have given a command x.legend just to show the legend. So this we had discussed yesterday, and we had discussed how to change the positions also of the legend. If you don't give any argument, then it takes the best place where the legend can be displayed. Any question, any query on this? Anyone? Okay, very nice. Okay, so now, for example, if we want to handle this legend, I want to move it outside. So many times it happens that legend is inside and it is covering the graph. For example, here it might have covered some line. So for that, there is a command which is called bb box to anchor. So when you give this command in x.legend, bb box to anchor, so here you can define the positions. So here again, what I'm doing on the same plot, I'm making figure and axis named X. In the same, I'm plotting 1, 2, 3, label is data A. I'm plotting 3 to 1, label data B. And I'm passing legend. So B box to anchor can take values from 0, 0 to 1, 1. 0, 0 means left bottommost. 1, 1 means rightmost. So if I want to display my legend outside, so I will pass 1.05. 1 location is upper left, but this 1.05 by 1, it will immediately take rightmost upper right. Use the tight layout. It has got only one axis, so this command is unnecessary here. But it is a good practice to use this command, so it becomes our habit. So by this, I can change the location of the legend. Now let's see if I had not used this and I had used only X legend, what would have happened? So see, your legend has come inside, and in many cases, it might make your chart unreadable by camouflaging your lines or your data. So that's how you can control your legend position.
What the parameter is doing, the 1.05 and 1.
Like I said, 0, 0 starts from left, below most, okay?
Yeah.
And 1, 1 is the top. 1.05 is putting your legend outside to the right. So this 1.05 which is there. Let's do 1.10 and let's see what happens. It will shift more.
The 1 will be counted based on the figure size.
It is on the figure size, yes.
Okay, after that it will start
Yeah.
1.2 or
No,
okay,
no.
if you
See, everything is inside your figure. You don't display anything outside figure. So your canvas remains the same.
okay, then 1 where is 1? The corner of the top right.
Yes, this is 1, 1 and you're displaying legend outside.
Okay, suppose we change the size of this 1 by changing this plot.
We have changed, for example, 1.5. So you are shifting.
We are changing a legend, no? Suppose
Okay.
we change with the box.
Okay, so what will you size? Fixed size?
Yeah. If we change the fixed size, then what will happen with the legend?
I will request all of you to please basically practically participate and please check yourself also.
Yeah, just to know how
No,
it is working. Then we will check.
so actually these kind of things you can check and see it has shifted more here. Okay.
Okay.
You can go back, you can check that, and next day we can discuss that. Okay.
Okay, fine.
Yeah. Okay.
So in this chart, how is it getting the X and Y values?
Which one?
Like AX dot plot, we are giving only a list, right? So that is one dimensional, but it is having X and Y axis.
No, I'm passing 1, 2, 3, 1, 2, 3, which is there. So the values have come 1, 2, 3, and then next value I'm passing 3 to 1. Okay. So if you don't pass X, so it will plot only Y values. Okay.
Okay, so I'm saying that there is no X, Y coordinate.
Yeah.
There is only list of one-dimensional value. So how is it
Okay.
getting
Okay,
X?
so I'll just show you. So if you don't pass X, then your this first list which is there, for example, here I'm not plotting 3 to 1. Then this 1, 2, 3 which is there, it is a solid line connecting points 1, 2, 3. So it takes this as a Y value. Okay. Okay. Yeah.
So
And X
I
value
just
will be
one.
what, sir? So what will
Yeah.
be the X values?
X set is taken dynamically. There are no values. Okay. There is no relevance of these values which are there.
Okay, sir. Yeah, understood.
Okay. So this has come by default. So I could have given here, for example, X dot plot. If I give here 1, 2, 3. So now here it will take. Okay. Earlier it took default values. So now here on the x-axis it is plotting 1, 2, 3. On y also 1, 2, 3.
Okay, sir.
Yeah. Okay. So there is
Excuse me, sir.
yes.
Sir, what is the significance of the location parameter? Upper
So,
left.
yeah, location parameter, this BB box to anchor which is there, by playing with these numbers which start from 0, 0, 0, 0, 0 means you're here, you're at the bottom left, and 1, 1 is your top right. So by playing with this, you can put your legend outside this axis which is there.
But sir, the numbers themselves seem to do that purpose. So what's the point of the location upper left?
Okay, just hold on, just hold on. It is not the upper left. Okay, yeah. If we don't give also, it will pop. Okay, just hold on. I'm giving this X legend. Okay, so your legend has come without giving that also. So basically BB box to anchor which is there, it is overriding your position which you had passed earlier.
Okay, sir. Clear.
Okay, yeah.
So any one we can use.
Yes, yes. But by giving this, you can control where you want to display.
Yeah, move it away from the axis.
Yes, yes. For example, if I do 1.5, I'm moving it away.
By
Whereas
default, it will
location
be
is
inside.
not.
By default,
it will
by default, it will be inside.
inside. Then if you want to put it outside, then the B box will be used, right?
Yeah, BB box anchor.
Okay.
Okay. So these are some checklists which are there when you are building a graph or a chart. First of all, you have to ask yourself about the markers. Have you highlighted the points? Number labels. Can I read the exact values without guessing? So basically, whether the bar label, it is on the top or it is in the center. Then the grid. So you have to be careful when you use the grid, because many times the grid makes your chart, look messy. So do you want it? Or if you want it, then please use faint grids with colors which are subtle, like light gray. Then the lines. Then lines. If I'm plotting different of the lines, then I can use different styles and different colors. So these are the basic things. Now with this, I have covered all the basics of Matplotlib. Before I move to give you a demonstration for a real world case, any query, any doubt, anything, you can pipe up, or we can take a 2 minute break.
Sir, can I add something?
Yes, Somapati ji.
So regarding that legend being positioned outside the graph, it will be very useful when we are defining the size of the legend. In this case, we have only one. Sometimes we will have 7 or 8, and our graph will be completely occupied, the figure size.
Yeah.
So that time it is advisable to take the legend outside for more clarity. That way it will be very useful.
Yes.
I'm just adding.
Yes. Yeah, definitely. Thank you so much. So you're right. When you're plotting, for example, 4 axes and your legends are inside, or they become unreadable, or they are camouflaging your data or the lines, that is the time you would like to take your legends outside. And one standard way of what I displayed was 1.11, which is mostly which is used, because having your legend right outside your axis, it gives you much more visibility and clarity. That's a standard way. So with this, I will just take around 3 to 4 minutes of break, just assimilate everything. We will join after 3 to 4 minutes, and then we will start.
Okay, sir. Thank you.
Yeah, Ramya, good evening.
Hello, good evening, sir.
Yeah,
So I have a question regarding coding in general. Can I ask?
yeah, please.
There are a lot of arguments while coding. I tend to forget them a lot. And my question is it normal or should I be really accurately remembering all these arguments?
No,
And
no. So, see, for a fresher, it is normal. So, we have to go back to our school days. When we were in LKG or UKG, learning alphabets was difficult. But as you keep on practicing, as you keep on evolving, then you start remembering. Okay, so just make a practice. And like I advise everyone that if you're doing this course, make a habit of, to code every day. If you code every day, it will come. Okay.
okay, sir, thank you.
Okay, so we will start with this workshop. I will not go beyond the scope of the workshop, otherwise, we have got limited time. We can discuss Guddu Mishra, the things later. That assessment has been given to you for something. Use your brain, whatever you have learned during your diploma. Okay, let's go. Okay, so now what we will do, we will try to use all these concepts which we have learned till now, and to visualize a real world use case. So for that, I'm taking Titanic data set. So Titanic data set is is an excellent data set to practice your machine learning skills, whether for visualization or for feature engineering, EDA, feature selection. So with this, I will do first use Titanic data set. So for that, I'm importing Seaborn as SNS only for the purpose that Titanic dataset is available in this library. Otherwise, we are not starting Seaborn. We will still use Matplotlib only. So let's get this data. So I'm importing this data as df, and let's see info. So it has got a target label which is survived. It is a passenger class. Sex means gender, age, sibling support, parent support, pair, embarked station, which is a categorical class. Then it is a class. What all classes are there? Again, categorical. Who, again, it is a gender. Then adult, male, true or false. So these two, one, two, and sex, which is there. So you can think that you have to keep either of this, otherwise your model will overfit. Just to give you a hint to Guddu Mishra. Now this is a DAC, whether the passenger was on DAC or if he was on DAC C. So the survival in Titanic also depended on the DAC. This is the important thing. Embarking town, I don't think that will make any difference to survival. Only if it is a,
Titanic also CSB, no?
yeah, it is a CSV. Yeah, it can
CSV.
be, it can be imported in any format. It is available in TXT also. It is available in Excel also. But when you are loading from SNS, Seaborn, you give the load data set and you give the name of the data set. Here you are not using pandas. Okay, alive.
Okay.
So, okay, so these C, alive and survived, they are same columns, only they have been encoded. Alone, yes or false. So this all information is there. And so 891 non-nan are there. So we can see age has got null values. You got null values in DAC. So let's now try to do some analysis using visualization on this. So first we will use bar chart. So yesterday we had learned a very, very important thing, that bar chart is used for categorical data. And it is used when you are comparing groups, for example, male versus female, or first class versus third class. So that, for example, we can check which passenger class had the most people. So what do we do? If we use the pandas, we find the df class dot value counts, which gives us the number of values in different classes. So it has given me third, first, second, the numbers. And now these class counts which are there, I can plot them using bar chart. So again, please pay attention here that in Matplotlib, I have to find the class counts and then I have to plot it. When we will come to Seaborn, you will realize that in Seaborn, you can directly do it without passing class counts, or without calculating class counts. That is the beauty or the strength of Seaborn. So we have taken this data. So this is my data class counts. I have made figure and axis, standard command, which we learned yesterday. And I am passing now x.bar. So I'm plotting a bar chart. I am passing class counts dot index, because see, this is the index. So third, first, second, they will come on the X label. This is my Y. What is that? It is a class counts dot values. So these are the values. I'm giving color gold, gray, brown for 3 classes, putting a title, setting Y label, setting X label, and plt dot show. So here,
we can take, suppose no more than one classes are there, we can select any class of that data.
so that data you will have to define here. Here,
Yeah.
Matplotlib will not decide your data.
Okay, in that, suppose df class is given in the red, that class name can be given. If more than one classes are there, we can put only one class out of that also, or more than one class also.
So like I mentioned, you have to define your data.
Only one class we have to take it for this.
One class means that you want to plot only third.
Yeah, suppose more than one class is there.
Okay, so you
or
can,
columns.
so then you have to use pandas to make your data.
Okay.
Presently, your data is having 3 classes. Okay,
Mhm.
so your class counts which is coming, you are plotting this.
Mhm.
Okay, this where I'm moving my mouse. So you are plotting this.
Yeah.
If you want to
Okay.
plot only one column, then you have to prepare your data accordingly.
Okay. Here we have already prepared class.
Yes,
third
yes.
person.
So
And
in
that we are plotting here. Yeah.
yes, so in
Okay.
Matplotlib, we have to prepare the data and then the pass the data in the X and Y. Okay.
Yeah. Okay.
Okay. So I will share this Colab file with you, all of you.
Mhm.
Now, what I will give you homework. Now you put the numbers on top of the bar.
Okay, fine. We will do
Okay.
that.
Yeah. Okay. Now we come to chart type 2. So these charts which I'm covering, these are the most frequently used charts used in the machine learning models when you're doing the EDA. The second chart type is the histogram. So histogram, like we had understood yesterday, it is covered only for one column and it gives you the distribution and it is used for numerical data. So for example, in Titanic, we know the numerical column is here. You can see here is the age. Okay, so it is a numerical column. Now we also know that it has got nan values. Now I will cover a very, very important concept here, that before filling the nan values, you would like to check the distribution. Now to check the distribution, you will have to first drop those nan values. Otherwise your histogram will throw an error. And once you see the distribution, then you will decide whether I have to use mean or median to fill my nan values. Okay, so for that, so what I've done, I've taken the data ages, I have dropped NA values. So this is my data, I have prepared my data, and then standard I'm making figure and axis, naming them fig and x size. And now I will plot histogram by dot hist, where I give the data, I give the number of bins, I give the color, I give the edge color. Okay. So see, this is the power of visualization. So immediately I know it is a normal distribution, but it is slightly skewed. So for me, it is better to fill the nan values with median. Now I will cover here, if you change the bins, how do we define the bins? I said the bins are 20. So let's see if I decide only there are 5 bins. So in 5 bins, when the data is less, it is very, very difficult to make out to the distribution. That is the limitation to that. If I increase the number of bins, for example, to 100, then see again it becomes clustered. So that is how, again I increase, for example, to 200, it will become more clustered. So here again more clustered is there. So basic idea is basically if you are having few 2 bins, then it is too vague, and you are having too many bins, it is too messy. However, if you don't give bins also, then automatically the bins will be displayed. Okay, so this was for histogram. Now we come to the next is the scatter plot. Scatter plot is used when
Where were you changing the bins 100 to 200? Bin size.
this is okay. Here is the argument.
Okay. Bins. Okay, bin
Yeah.
size. Okay.
And yesterday when we were covering the histogram,
Yeah.
this chart, okay, I think I had covered this, the arguments for hist.
Oh, good.
Okay, the bins are used as an argument in the dot hist.
Yeah, histogram. Yeah.
Okay, now we come to the scatter plot, like we covered yesterday. It is used to find relationship between 2 numerical columns, how they are going. So by that you can find collinearity, or you can find some kind of correlation. So that can give you an indication. For example, did older people means age, that is a numerical column, did they pay more fare for their ticket? So it is again a numerical column. So I prepare, for example, df.age and df.fare. I'm giving the color and the standard here. So see, if you see immediately now, you know that there is no correlation between age and fare. Okay, so that is the power of your visualization. If it would have come like this something, then we would have known that there is some linear function or some linear relation between the fare and age. Okay, we can change the this color also. So here we have seen color red. This is the alpha is the depth or the size. We can use blue and changing 0.1. So 0.1 C, it becomes very, very light, and color. So these are the arguments which you can use. Now here I can ask a question. For example, immediately I can come to know that who are these people who are paying more than $200 of the fare. So you can see they are in all ages. So they are starting from here, they are till here. So that gives me some indication about my data that these might be some people who are rich. So there is no relation between age and ticket. However, it gives me an indication that these are the people, they might be from the rich class. Okay. Now we come to the next chart, which is pie chart. And again, to cover what I had covered yesterday, it is basically to show percentage shares, and it is used when my categories are less than 5. If it is more than 5, then we don't use it. So for example, I will prepare the data. So I will have df.alive value counts. So let's see how does it look like before plotting it. So see, I have got around 549, those who didn't survive, 342 survived. So just to see this in a pie plot, I can plot it, which gives me percentage also. So here in a pie plot, we give only one data like a histogram, survival counts. I'm giving labels. Labels is the survival counts index, which is yes or no. I'm giving auto PCT for decimal value for the percentage. These are the colors matching which come from Matplotlib. There are various color combinations are there, which you can check the library and you can use it. Or you can pass here blue and red also, it will come. So here it has come no 61.6 and 38.4. So by default here, your percentages, they come and with the labels. So labels have come from here, no and yes, and percentage has come, decimal you have defined here, how many decimals you want, and you have defined the colors here. So this is the pie chart. So like I mentioned earlier, pie charts are only good for 2 to 4 categories. More than 5, please don't use it. Okay. Now, once you have made a graph and are using whether a Jupyter notebook or a Colab, then how to export your graph. So for that, the command is you have to save the figure. So the name of your figure, fig dot save fig, this is the command, and then inside give the name and you give the DPI, basically the pixels, how much you want, how rich it is there. So this is to save. So if you are using Colab, so immediately you will realize here your name of the file, this file here. So Titanic survival chart PNG has come here and you can download from here. Okay. And if you are using Jupyter notebook, so then this PNG will be saved in your present working directory from where you are using your Jupyter notebook. You can go there and you can find this. With this, friends, I have covered Matplotlib. Before moving to Seaborn, any question, any doubt, any discussion, please pipe up. Yeah, Papati ji.
Sir, I just wanted to ask whether we can split to that pie chart.
Okay, we'll find. Yeah, we'll find out. We'll come back. Okay.
Okay. Okay.
Yeah. Yes, Vikas.
Hello. Hello.
Yes, Vikas Pandey.
Yeah. So actually, sorry, I joined a little bit late. So have we covered mesh grid and other vector visualization in this session?
We have checked. We have covered the grid lines. Yeah.
Okay. Mesh grid and other stuff.
Mesh grid, okay, generally for the data science, okay, mesh grid is not used. That's why it has not been covered.
Okay, for data science, it's not. Only for mathematical side. Okay.
Yes, it is used for mathematical and the statistics, and that's why it has been kept out of the scope from there.
Okay, so it would not be covered in these three sessions.
No, it will not be covered. See, Matplotlib has got what I'm covering. I'm covering maybe hardly 15 to 20% of the relevant things which are relevant for machine learning and data science domain. Otherwise, it is a very, very vast area, and the workshop can be conducted even for a month if you want to cover all the topics of Matplotlib.
Okay.
Okay. Yeah.
Thank you for.
Yeah. So we'll just take a pause before we move to Seaborn. Please try to assimilate. Please try to remember all the parts, because once we go to Seaborn, you will find Seaborn does a lot of things automatically. So we don't have to write so many codes for Matplotlib. But the important part is that if you want specific implementations, like you want to display the numbers on the top of the bar, then along with the Seaborn, you have to use the Matplotlib also. So very, very important to remember these basics of Matplotlib. And another thing is that you should know what kind of chart is to be used. That is the main takeaway from this workshop, because you will be having a lot of data sets. So immediately you should know that I'm having a numerical column. What should I use? How do I analyze it? How to see the distribution? I want to see, relationship between a categorical column and my labels. How do I do that? So if it is a classification task and there is a categorical column, immediately it should come to my mind that I will use a count plot. So that I will cover during the Seaborn. So like yesterday, I had covered the 12 types of charts. So I had covered, basically, I had given you the nickname of that chart. I had given you the question that if this is the question, then you should be using that chart. And I had given you the real world use also. And by doing this tightening, I just gave you how it can be used, and it can make your life much, much comfortable. And when you go for real world projects, like there is an assignment going on for all of you for the classification and regression. It was launched day before yesterday, and somebody had submitted yesterday morning saying that my accuracy is 0.85 and I cannot improve it, because you have to do a lot of analysis. You have to analyze each and every column. So like by seeing the Titanic data set, I could immediately see from the info that there were 2-3 columns which were similar. If you keep all the columns, then definitely your machine learning model will overfit. What more feature engineering can I do? Can I make something that if I'm alone and if I was young, then my chances of survival were less. If I was with my family, my survival was more. If I can visualize the survival count by gender, then immediately I will come to know that which gender had a survival probability higher, and in which age group. Maybe the young people, they had decided to support the old people, and especially females. So all this data which is there, the EDA which you are there, you have to ask these questions, and then you have to do feature engineering. And this data visualization is very, very handy to build those intuitions and instincts. Okay, let's move now to
Sir.
Yeah.
Sir, one request, sir. After the doing this our workshop, could you take some real-time data of Kaggle or like the not toy data to implement all these concepts on this particular unknown data?
So what I will do, I will give you a
One numerical and one categorical at least.
No, Shrikant ji, it is not possible to cover each and everything in the workshop. What I will do at the end of the workshop, I will give you one notebook, which is a very, very extensive notebook where everything has been done by me, everything.
Okay.
And it took around 1 week for me to do all that analysis. I'll give you the YouTube recording also. All of you can go through that, and it is covered in a instructional way. So every step of a machine learning model has been covered from the basics.
Okay, fine.
Okay, how do you feel the data? How do you do all this analysis? Okay.
Yeah, that's why I'm asking. So I will follow that recording and we'll do on that too. Okay.
Yes. So watch that recording.
That's what I wanted, because without doing we cannot learn it.
Yeah. Okay.
Okay, fine. Thank you.
Okay, let's move to Seaborn. So today we will just touch the Seaborn, and tomorrow we will implement everything on Seaborn. So just to give you the basics of Seaborn, it is an amazing visualization library for statistical graphics plotting in Python. It is built on top of Matplotlib. It provides beautiful default styles and color palettes to make your plots more attractive. And it is also closely integrated with the data structures from pandas. So you can say that Matplotlib is like a manual camera that you have to control your focus, shutter speed, and ISO. Great for professionals, but slow for beginners. Whereas the Seaborn is like a portrait mode on a smartphone. It automatically makes things look good and handles the math for you. So if Matplotlib is the engine, your Seaborn is the luxury car which has been built on top of it. Okay, so that is the analogy. So I will say Matplotlib is great for low-level control, for drawing the pixels, axis lines, where the Seaborn is great for statistical exploration. And you will find majority of the data scientists or the machine learning, people who are making models, they work with Seaborn, but they also extensively use Matplotlib features to bring, much more clarity. So the key difference is that if you have to write some 10 lines of codes for Matplotlib, you can do the same with a single line of Seaborn. And it has got built-in statistics. It calculates means, confidence intervals, and the frequency counts automatically. So when you are using Seaborn, don't think it is happening everything automatically. Behind the scene, it is calculating, whereas in the Matplotlib, we had to prepare the data. So here in Seaborn, it is preparing the data. It is not displaying to you, but its engine is working. It is finding, and then it is displaying. The aesthetics of Seaborn are slightly better than Matplotlib. Okay, so when we use the Seaborn, we always use Seaborn in conjunction with Matplotlib. So always you have to import Matplotlib as PLT and then Seaborn to work with that. Okay, so this is a standard command, and like I yesterday mentioned, it should become ingrained in our subconsciousness to import them. So import matplotlib.pyplot as PLT and Seaborn as SNS. It should be our starting when we are starting a Matplot machine learning model project. So I import NumPy as NP, import pandas as PD, I import matplotlib.pyplot as PLT, import Seaborn as SNS. So it has ingrained in my subconsciousness. These are the 4 basic libraries. Okay. Now second is, in Seaborn, we have got a command called set theme. So here you can set a theme by giving styles. So you can explore different styles. This has got, it makes your backgrounds nicer. For example, white grid is one of the style which we'll use here. I will display to you different styles also. Now here, to cover here, we will load 2 data sets. So one is again from Seaborn, one is tips and another is Titanic. So tips data set has got total bill, it has got a tip, sex, gender basically, smoker yes or no, categorical, day again categorical, time categorical, size was the size of the people who died. The Titanic data set, we have seen this data set, so I don't have to explain this again. So we will be using these 2 data sets, like just now Prashad ji had asked me. So for this Seaborn, I will give you we'll explore the visualization using these 2 data sets, and we'll take some few more data sets also as we go. Now, like for Matplotlib, we had covered the 12 basic types of plots. Here, these are the Seaborn plots. So first plot, we can club them as relational plots. So these plots are used to understand the relation between 2 variables, like a scatter plot we saw in Matplotlib. The second type of plots can be grouped under categorical plots. So they deal with the categorical variables and how they can be visualized. The third type of plots, they can be grouped in distribution plots. So basically they can be used for examining a univariate or distribution or a bivariate distributions, how 2 columns are interacting with each other, how's the distribution. Then we have got regression plots. Regression plots in Seaborn, they can give me a regression line. Many of you might have used during your MLP project. So basically they add a visual guide which helps to emphasize patterns in a data set during EDA. Then we have got matrix plots, which are a type of scatter plots, and we also have got multi-plot grids. So all these type, and I'm using the resource, the documentation from Seaborn library. This is the link for that. You can explore more. Now we will go like we had done for Matplotlib. Here we will go analysis wise. For example, I want to carry out a univariate analysis. Univariate analysis means that I am looking only at one variable. So, and I want to understand this column deeply. For example, I'm building a machine learning model for Titanic data set, and the column is age. So I want to understand that very, very clearly how that column is there. What is the distribution? Okay, so what all things I can do? So first I can know the distribution or a frequency of a single column if it is a numerical column. So for that, the plot is hist plot, and hist plot, what is there? It is a histogram, and it also gives me KDE. KDE means kernel density value. It is a hist plot. So it gives me the shape of data. Basically, it is, if the question is that how the total bills in the tip data set distributed, are they mostly cheap or expensive? So this is, I will use this hist plot. The use case is checking age distribution, or the salary ranges, or your tip ranges, or your total bill ranges, what is there. Now remember, when you are using this hist plot in the Cgram, the KDE is equal to false is default. I will write it here. You have to give KDE is equal to true to see this distribution line. Okay, so for the histogram plot, Matplotlib, we were using plt.hist. Here we use sns.histplot. We give data is equal to tips. So in a Seaborn, we have to provide data. In every command, you will have to give what is the data. So here I'm giving data is equal to tips. What is the x? X-axis is total value. And here I'm doing the histogram of this, so I don't have to pass the y value. KD is true, which will give me the line. Color is teal. And then I give the title and plt.show. So again, remember, the Seaborn is built on Matplotlib. So first I have to define the figure. So this is my figure, plt.figure. Fixed size 85. So here I have made the canvas. I don't have to make axes here. And I'm just plotting sns.histplot, and Seaborn automatically it is making an axis, and then using the Matplotlib plt.title, I'm giving the title and I'm doing plt.show. So takeaways are like that, that you are using the concepts of both Matplotlib also and Seaborn also in this. Okay, that's
PLT is coming from the Matplotlib.
Matplotlib. We had imported, I had covered here. Please pay
Okay,
attention. Okay.
Yeah,
Okay.
that PLT is coming from that, and SNS is coming from the Seaborn.
Seaborn, yes.
And in the SNS, the syntax of this SNS, his plot. Okay, this is the default syntax. Now, data will be default name, the keyword.
Data is the keyword. In
And
SNS, in Seaborn, you have to give data.
Okay, data is the keyword, and X is also keyword.
X is keyword.
Okay, and then we have to fill this right hand side of this equal to sign, right?
Right hand side means?
Tips is the variable. No, we have given the data, name of the data, right?
Yes, tips is the name of the data set.
Yeah.
What I am plotting the histogram of total bill.
Total base of that column.
Okay.
Fine.
Now for a histogram, there is no y axis. So I am not passing any y.
Okay, got it.
Okay, I am passing this kernel density estimate is equal to true, which will give me the line.
Yeah.
Okay, and I'm passing this. And again, I'm using the Matplotlib concept for giving the title, and I'm passing the plot.show.
Okay, fine. Okay. Thank you.
Okay. Now
the difference between Matplotlib is, in Matplotlib we will have to give a series like tips and total bill column name, whereas here we just like a string we are passing x value. In
so in Matplotlib, if you go back and check the collab, in Matplotlib, we don't part the data set. We pass only the data. Okay?
Yes, like a list or series.
No, whatever is your data you could have passed. Okay, for example,
Directly,
I'm just
directly you put the data in place of data is equal to tips. We directly put the tips, right?
you will pass tips total bill.
Yeah,
Okay.
tips. Yeah, tips total bill. And here
Okay.
we are defining assigning the data as a value to that variable. That is a keyword
Yes.
data in X.
So
Correct.
in Seaborn, data is always used. It is a keyword. Okay.
And X is the column name.
Yes.
X is the column name, like total bill.
X is the histogram. In a histogram, you give only one value.
Yes.
Okay. So you're passing that parameter.
So I have one doubt here regarding
Yeah.
the y values. So in case here you have shown the absolute counts, but instead of absolute count, if I want to show, say, the relative frequency or probability on the y-axis, then how do we show it in the histogram plot?
In the histogram, we will see it. Okay. We'll come to that. Just let's build gradually one by one. Okay. Okay. So see the syntax here. See the syntax. The command is histplot. You pass the data, you give X, you give KD is equal to true if you want to see that this line of distribution. By default, KD is equal to false. That is a default. Okay. So you can see your distribution, how it is looking like. It is like a normal and right is skewed. Okay. Now in Matplotlib, if you want to draw this line, then you have to do a lot of maths and then to display it. Whereas in Seaborn, it was just one word. And like I mentioned earlier, KD is false in as a default. So if you don't give KD is equal to true, you will see only the distribution and you got the counts. Okay. Now, second type of plot for the univariate distribution is dist plot. Dist plot, basically, it will plot the histogram with some other variable like KD plot or the rug plot. Now, this dist plot in Seaborn has been depreciated. Again, re-emphasizing, it has been depreciated, so you don't have to use. So, see, for this, I'm making a data. This is random state I'm giving. I'm giving rs.normal. I'm preparing this normal distribution. Size is 100. I'm passing the colors RGB. And then I will plot a histogram with multiple colors. So when I use SNS.dist plot, then I have to give the data D. So I can give this as data is equal to D. It's a keyword. I give KD is equal to true. I here pass hist is equal to true to build a histogram. So I am building a same histogram, but using a dist plot. So in Seaborn, the beauty is that you can make the same chart by different ways. There are two ways. One, you can pass inside or you can pass outside. I pass bins is equal to 10. I give rug that the distribution it will come. I give hist KWS alpha 0.3 color. These are the parameters to define your histogram, how it will look like. And similarly for KD, I'm passing color. And for rugs also, I'm passing color. So let's see how it looks like. Okay, data is not there. This is X. Okay, D. And like I mentioned, this is depreciated now. You can see here also it is written dist plot is a depreciated function and will be removed. So instead of using dist plot, now we use hist plot, which is a straight away and gives you the KD. But if you go through the various notebooks, for example, on Kaggle and all that, you will find this. So you should know that how the dist plot is there. So it is also giving the same distribution and the rug which was there. So rug is the number of values here. So these are the small blue things which are there. These are the values, the rugs which are there. So you can know the distribution from here also. Okay.
So
now,
what do you mean by rug means?
Rug means these are the values. When you have made this data here, this data which you have made, these are the 100 values are there. So this 100 values, how they are distributed. One value is here, There are two here, here.
Okay, this is taking the values from the what we created normal distribution.
Yes, yeah,
R value.
yeah.
So using ist plot also can we use rug?
Yes, it can be used. We'll see. See, Seaborn is very extensive. You can have, like I mentioned earlier, you can have the same chart using different methods also. We will be seeing all those methods. That's why in the Seaborn, the first important question is what kind of column is that? What kind of analysis I want to do? Whether I want to use count plot, whether I want to use the, see the distribution. So first the questions, they should come in your mind, and then you will get the chart. Okay. So here again, I will give you everything in that form only. That what is the question, what is the real world use, and example. Okay. Presently, I'm covering the basic charts which are used in histogram, and then we'll go slightly deep. We'll start covering that. Okay.
Yes, sir. I asked because the disk plot is deprecated.
Yes. So I covered earlier also that now in place of disk plot, you can use hist plot. And there is another way also where you can pass the argument. So there is one plot called disk plot, DISPLOT. Okay?
That is only for the histogram, no?
That is for histogram.
Okay.
No. Disk plot, you can give the kind here. So here see kind. You pass kind here.
Kind
Hist
of
is equal to true. Okay.
Okay.
We can give rug is equal to true. So similarly, instead of disk plot, there is another plot which is known as DIS plot. Disk plot, distribution plot. Okay. That is still invoked. And in that you can pass the argument rug is equal to true. Now,
Okay.
Now we come for line plot. So line plot we had seen in Matplotlib. I will be covering the similarities. I will just to refresh your memories. So in your Matplotlib, how do you plot your line plot? Anyone? What is the command?
plt.plot.
plt.plot. Very nice. Okay. Now for displaying this line plot, this is the basic most plot in the Seaborn library, mainly used to visualize the data in form of some time series or in a continuous manner, like we had covered in Matplotlib. Here we will use a data set called fMRI from Seaborn. And so let's see how this data set looks like. So basically, I wanted to give you time series basically display. For that, I'm using this. So it has got subject, it has got a time point, it has got an event, it has got region, and then it has got signal. So this is a subject, this is a time point, event, a region, and the signal value. Okay. So what I want to plot here now, on X, I want to see the time point. What is the time? On Y, I want to see signal. So first I will show you the basic one before I touch hue, which is a new concept which was not there in the Matplotlib. So I will not give this anything. So see here, like Seaborn I had covered earlier, you have to give data, then you have to give X, you have to give Y, because for line plot, it expects this, X and Y. So this data which has come in the line plot, so your line has come, and these shapes which are there, basically they are your distribution or the confidence intervals. That what is the standard deviation or the confidence intervals which are there. There is a way to remove them also. We'll see that. So, but when you plot a line plot, this is the default one. This is how, which is different from the Matplotlib. Now, there is an important concept. Yeah.
What is this fMRI?
fMRI is the data set which we have loaded.
Okay, the name of the data set.
Yeah. Am I going too fast? Shall I slow down?
Yeah, slightly. 10% to 20% slow.
I think I will advise you to increase your slightly speed. Okay.
Okay,
And pay attention. Okay. Otherwise, we will not be able to cover this workshop, complete this workshop. Okay.
Okay.
Yeah. Now, this is a new concept called hue. Hue means when I pass this command hue and I'm passing region, then what it will do, it will plot this line for different regions. Now you see region was a column, which is a categorical column. We can see what is the type of how many unique values are there in this. So data set we have as fMRI. That's its unique values before plotting it. Okay, so it has got two values, parietal and frontal. So when I use this hue here, it will give me these two lines now for both, for parietal also and for the parental also. This is one power of Seaborn, and this is extensively used. Okay, for example, you are using for Titanic, and you want to plot the, for example, age or with some other x-axis, and you want to see for gender, then you can give the hue as sex, and for both the sex it will display the data. And this hue can be used in almost all the plots of Seaborn. So let's see how it is done when we pass. Okay, so see here, it has come, and again it has come for the different. Now here I had passed one something called style, so I will just deselect it. So see only hue first. Okay, so now you see for both parietal and frontal the lines have come, and they have come with the confidence intervals. Now second argument is style. Now again you see style, this if I pass this argument, style is equal to event. So there are different types of events here. I can see what are the unique values of these events. So there are two events, stim and q. So when you pass style, it will give for region, and it will also give for these two events also. So see on top here, it is giving this legend also, and legend is coming automatically. We are not passing any legend here. So it is giving region, which is coming hue, parietal, frontal in the solid lines, and for event, stim and q, they are coming here, and it has given the q. Okay, so this is the power of Seaborn, that using one just chart, I can visualize 2-3 things simultaneously. In fact, I can visualize 4 things also simultaneously in Seaborn. We will see those ways also. Any question in this part, anyone?
So are the confidence intervals included automatically? I mean, without passing on any parameters?
They are default. They are default. However, if I don't want to see them, then I have to pass an argument.
Could you please show which argument would remove the confidence interval?
Yes, we will go. We are gradually moving to those parts. Okay, let's see one by one.
Hue, style, and data is the keyword, right?
X, Y, hue is a optional argument if you want to see hue by region. Style is also an optional, but data, X and Y are the mandatory arguments.
Okay, fine.
Okay. So U is showing two lines, right? For parietal and frontal separately.
Yes. So because I have passed hue as, I have passed, for example, again I will cover it. I deselect style. I select only hue as region. So it will give me these two lines. It is a line plot. So it is giving me for parietal. So this blue line is for parietal, and this line is for frontal. I am passing style for event also, that I want to see with the event also. So I can visualize for both. Okay, now for parietal also, see parietal is blue here. For which region? For stem region. For Q region, this is the parietal, downward, dotted line. For frontal, this is the line for stem region. And this for below line, this is for the Q region. Because we had seen that there are two regions, stem and Q. Okay, so I can see region wise also, and I can see event wise also. So this is the power of Seaborn. Okay.
So we could have given U as event and style as region also.
Yes, you can do that. Okay. Now we come to next plot, basic plot, LM plot. So again, LM plot, we don't have a similar plot in Matplotlib. LM plot, basically it shows a line representing a linear regression model along with the data points on a 2D space, and X and Y can be set as a horizontal and vertical labels respectively. So to demonstrate that, I will use a data set called Anscombe, and let's see how does it data set looks like. So it has got only X and Y values. Okay, so it has got X and Y values. Now when I plot LM plot, I have to pass X, again Y and data. So this is the commonality in the Seaborn charts. You have to pass data, you have to pass X, and you have to pass Y. So I had defined here, for example, ensemble LM plot. Data is DF, so it takes this data X and Y. And when we plot this, immediately it gives a linear regression line. So this is a very, very powerful tool when you are trying to build an institution or some intuition that how your columns, when you are analyzing a data set, how they are correlated. What is the regression in that? So for example, if you have got a numerical column and your task is a regression task where you have got a target label which is continuous in nature, immediately by plotting this, you can see the relation between that column and your target label. Now by default, this line comes, but if you want to plot this LM plot, the basic purpose is to see this line only. Okay, you can select also not to see this, but default is this line will be visible. And again, it has got the confidence intervals.
But LM stands for LM is linear.
Linear.
LM.
Yeah. Okay. Now, like I covered earlier, so there is a plot called disk plot. Now, disk plot is still in vogue. Now, with the disk plot, you have to, for example, it is a distribution plot. So distribution plot, immediately it comes to our mind that it is used for plotting the distribution. So like a hist plot, when you want to see the rug, somebody had asked me. So here you can pass, this is the color I'm building the data. Distribution plot, that is disk plot. I pass the data. I pass KD is equal to true because default is KD is false. I pass the number of bins and I pass the rugs also. Rug is equal to true. So if we do that, this is how we can see the rug. So rug is here, how the values are there. And distribution, we can see it is a normal distribution because we have defined it as a normal distribution without adding any noise. Okay. Till now, everything is clear, or shall we check again what all plots we have covered? So we have seen haste plot.
Yeah.
First part of the plot which was there. Okay. So we started from here. Then we covered disk plot. So like I mentioned, disk plot is now deprecated. So instead of disk plot, we can use disk plot, and it has got a similar kind of arguments. Then we saw line plot, which is very, very similar to Matplotlib line plot, and we use the fMRI data set for that. Then we came for, now in line plot, what we understood that it gives the confidence interval, and along with the line plot, we can use inside data X and Y, we can also use. Yes, some query from someone? Hello, am I audible?
You are
Yes,
audible,
sir.
sir.
Okay.
You are audible.
Okay. So in the line plot, it gives us the confidence intervals also. And along with this line plot and many other plots, we can use hue also to compare different categories, and we can also use style. Now, after line plot, we saw LM plot, which is basically shows a line which represents a linear regression model along with the data points. And then we saw the disk plot. Disk plot is basically to see the histogram or the distribution along with the KDE, and we can also pass argument rug is equal to true, which gives us this rugs. Now, so in the Matplotlib, we have back box plots. So similarly, here in Seaborn also, we have got the box
So
plots.
one question, sir.
Yeah.
The uses of this, suppose rug, it is showing here in the bottom, but what are the uses of this? Could you also
See,
explain?
use is like that. Okay, here I have made this as a, for example, a normal distribution. I know it is a normal distribution.
Yeah, yeah, yeah.
But for example, in your Titanic data set, your column is age.
Mhm.
Okay, along
Yes.
with that distribution, looking here, I can see from which age group the people were more.
Okay, it will show in between. Okay, okay. We can infer
Okay.
from that. Okay.
Yes, yes. Okay.
Yeah. The same thing if you add some another item in the
Yeah,
plotting
yeah.
and something also you the what is the use, how to use that,
Okay.
how to infer, because ultimately we have to use this visualization for the
Okay.
prediction.
So now you have
Okay.
understood?
Yeah, got it.
So
Okay.
this is also for seeing the distribution within a bar.
Yes,
Within a bar, we can see the distribution
yes, yes.
within a bin.
Yes, yes. You can see how many values are there inside that bin, which
Yeah,
is there.
in-depth knowledge we can
Okay.
visualize from
For example, there is something clubbed here. You can immediately know that here, there is a density here.
that.
There were a lot of
Yeah,
people here of this
correct,
bin.
correct.
Number of
Okay.
lines is the number of data
Yeah.
points.
Yeah. Okay.
So before moving forward, I just have a small doubt.
Yeah.
Could you please scroll up? I mean, in the previous histogram to the previous histogram plot.
Yes. First one.
Yeah. The one before that.
Yes.
Yeah. Just the next one. Yeah.
Yes.
So the one below. So in one of the histograms, I saw that density was on the y-axis, and the other one there was count. Was it because of the data, or was it? Is there? Yeah. Here it shows the density on the y-axis, right?
Yeah.
But did we specify anything in the plot? I mean, in the function, or is it the data itself that gives you the density?
It is automatically your data is being interpreted.
But in the other plot, it showed the count with the
Yes,
same
yes,
data set,
yes.
right?
So for
yeah.
So for that, like for example, this disk plot is there. It is not in use now these days. It is deprecated. Okay.
But why
Okay.
is it showing density for the same data set instead of count?
It is showing, but again, now we can compare, for example, a disk plot which is there. So basically, when we want to do the analysis, for example, what is a basic function or basic objective when you want to do an analysis by seeing a histogram? You are basically checking the density distribution. Is that correct?
So I understand one thing, that KD is basically density estimation. So KD true by default should give you density. But in one case, it's showing count. This is what's confusing me. In the disk plot, like in KD true, it's a density estimation, so it should give you density. But it's showing me
no. Please, okay, don't. So this KD which is there, this is the line KD.
Yeah, so but that's a density, right? It's a continuous line, so it gives density estimation. So KD by default should actually show the density and not the discrete counts, which is fine in the other plot, but here it's showing only count.
Okay,
even
okay. Just see. Okay. We remove the KD, then it is giving the counts. Okay.
But in the other plot, yeah.
So no. What I can see, when you give the KDE, KD is giving distribution, but it does not mean the number which is there, for example. So this is giving you a distribution. It is an estimate. Okay. Okay. I will find out more and I will try to answer maybe tomorrow. Okay.
All right, sir.
Okay. Yeah. Okay. So box plot we have covered, for example, for Matplotlib. Here also there is no so much of change. Here we pass X data. For example, we are passing X tips is equal to tip. You can have box plots for many other columns also, not only for one column. And by default, it is a horizontal. If you want to make it vertical, then you have to change it. So here I passed X is equal to tips. That's why it gave me in the horizontal. If I pass it as a Y, then it will give me vertical. Okay. So this we have seen. Now we come to, so till now we saw what kind of data. We were seeing the numerical data and what all we can do with that numerical data. We can plot a line plot, we can do univariate analysis, we can see the box plot to hunt the outliers. Now we come to categorical data. So categorical data, remember, in Matplotlib, we had to first find the value counts and then we had to plot them using bar plot. Okay. Whereas in Seaborn, we have got something called count plot, which does this finding value counts in the background automatically. So you don't have to do that extra maths. So that is the power of Seaborn. For example, command is dot count plot. Here again, we pass data is equal to tips. X is equal to day. For example, I want to find this. I'm giving the title using the Matplotlib command and plt.show. Palette is basically the color, how the color fade. So here, see, automatically when I passed X is equal to day, it has found what all categories are there in the day, Thursday, Friday, Saturday, Sunday, and it has automatically found the count. Whereas in Matplotlib, I had to find the value counts and then I had to give those value count index and value count values. So this is one plot which is highly used using Seaborn. But now the importance of knowing the Matplotlib is like that if you want to display the number here, then you have to use the Matplotlib. We will see later on how we have to do that. Now, in this count plot, again, I can use hue. So I can know these numbers. So if I pass hue is equal to sex and I'm using this Titanic data set, I'm finding P class and I'm giving hue. So it will give me P class now gender wise. So class 1, these were many females, these many males. Similarly for class 2 and similarly this for class 3. Okay. Now again, now for example, this is the second example. If I want to now display the numbers, so remember when we make something in a Seaborn or a Matplotlib, basically they are covered in containers. So here, this is the standard way. I first, build an X. So here, this is, I have named this X is equal to sns.countplot, pass the same arguments. And here now, for each and every container, this 1, 2, 3, these are the containers, I will ask that x.bar_label, which is the Matplotlib command. And I'm passing this C. So this C is a parameter here. So for every container, I'm passing padding, that how far it will be away from the bar chart, decimal place, font weight. So this is the concept from Matplotlib for plotting. I'm setting the set y limit from 0 to 600, again from Matplotlib, and then plt.show. So let's see. So see, now every bar, now I'm having a number. And what I have done, I have tried to demonstrate to you that you will have to use most of the times the concepts from Seaborn, and you will also have to use the Matplotlib. And when you have got more than one bar, then this is the command which you use. For C in x.container, where x you have defined your plot name, and then x dot bar label, you are passing this C as an argument, padding for the difference where your number will be displayed, and a standard argument of bar label. Any question here in this?
So this labels was easy in Matplotlib, right? Because
Which one?
we
This
had
bar,
to write a for loop here.
yes, this bar label is a Matplotlib concept. I will just write it here.
No, in latest version of Matplotlib, we didn't have to use this for loop.
No. See, here we are having in the Matplotlib, when you are doing the bar label, here your 3 charts have become. So I will just explain the container concept before we finish this today. And tomorrow we will again revisit all the Seaborn, all these charts. We will see the advanced techniques also. Okay. So basically, what is a container? Container is like when you are painting a wall, your plot X basically is the wall you have painted, and a bar is a single stroke of paint on that, and the container is the paint bucket. So this male and female which have come, this is one container. Okay, this is second container, this is third container. So then you pass this container as an argument here, that for C in X dot container. So this X has built 3 containers because there were 3 types of P classes. And now here you're passing a bar label command to these containers that you have to put numbers by giving this command. Okay, so that is the concept. When you are using the Seaborn, you will get habitual of using this command. This is a standard command in Seaborn to give the numbers. Okay.
Yes, sir.
Okay. So I think it is enough for today. We have to assimilate a lot of things. So there were 2 or 3 queries. I will discuss that tomorrow, and tomorrow we will cover the Seaborn in entirety, again taking the real world examples. However, here also I am trying to cover with the real world examples only, taking various data sets from the Seaborn library. So giving that. So with that, I have finished. If there is any query, you can pipe up. Else, I think 1 hour 45 minutes is a lot of time to assimilate and to grasp those things. Anything from anybody? Yes, Prashant.
Sir, in Matplotlib, that there was a dot labels some function method.
No. Dot labels we have not covered till now.
No, to give the label, like in Matplot, you said in the latest version we don't have to write a for loop for the.
No. So it was under bar underscore label only.
Yeah, yes. So
Okay.
we could avoid the for loop. Whereas in Seaborn, we just have to write the for
No.
C.
No. Prashant, you have not understood. Here we are giving this loop. We are using bar underscore label only. But why we are using this loop? Because we have to write in top of all the bars. If I don't give, it will write only in the first bar. So these bars which are there, they are like containers. I have to write, above all the bars. That is the reason.
Because you are using U. So
Yeah.
okay. Otherwise, no, only the first.
Yeah.
Right.
Yeah. Yes,
Now
Vikas.
Thank you for this very informative session.
Vikas, you are not audible. If you can type on chat, please.
Hello.
Yes.
So thank you for this very informative session. It's a great session. It was very required for understanding all these libraries for visualization. I mean, there was a huge need for it.
Yeah.
Thank you for
Thank you, Vikas. Thank you so much. I will.
one more thing I wanted to add, sir. Please
Yeah.
arrange the recording today itself for me. because-
Yes. I will share the recording itself today itself. Okay. Yeah. See, in Seaborn, like I covered earlier also, you can plot the same chart using 2 or 3 different ways. It does not have a fixed way like Matplotlib. So we will see all that. Okay, we can have, one type of plot, and inside we have to pass kind is equal to like this. Whereas the similar plot can be plotted using sns.histplot. So there are 2 ways. We'll see all of that, but Seaborn is very powerful. But again, I will reemphasize to use or to have more features in your chart, you have to know the Matplotlib basics. So you know how to, how you can plot the legend outside, how can make my marker, or how to make these numbers above these bars. Okay. Thank you. Thank you so much. Have a very nice day. Enjoy. Bye. Happy learnings. Bye-bye.
Yeah, thank you so.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.